built-up section and we need to calculate the modified slenderness ratio for built-up section. So shear connector are stay plates between the elements of a built-up member. So when we make a built-up section, so we need to provide shear connectors or stay plate between the built-up section. For example, we have this built-up section made of these two C sections, so we need to provide these stay plates, lacing or shear connectors. So the built-up compression member composed of two or more hot-rolled shafts shall be connected to one another at an interval by stay plates or shear connectors such that the maximum slenderness ratio A over Ri of individual element between the fasteners does not exceed the governing slenderness ratio of the built-up member, that is greater value of KL over Rx or KL over Ry. So what it means? For example, we have a box section made up of angles. So we need to use these lacing elements as well as tie plates to connect the section at different locations. So if we see in the plane, so we will, or in the elevation, it will look like this. So this overall section will have slenderness ratio Rx as well as Ry, mean KL over Rx and KL over R about Y axis. So the larger value out of these two will be the governing value. Similarly, if we see these individual sections, for example this one, so if we have tie plate, one tie plate over here and the second tie plate over here, so between these two tie plates, this much length of the individual member, so it can also buckle. So it will have a certain length L, and the radius of gyration of this individual member mean Rx, Ry or Rz. So the smaller value out of these three. So L over Ri mean R minimum. So this will give us the slenderness ratio of this individual member. So the slenderness ratio of this individual member should be less than the governing value out of these two slenderness ratio. So we need to design these tie plates or lacing elements in such a way, or these shear connectors in such a way, that the slenderness ratio of this individual member should be less than the governing slenderness ratio of the overall section. So this is because if the slenderness ratio of this individual member is greater than the overall slenderness ratio of the member, so the portion or this portion of the member will buckle before the overall buckling of the member. So we need to ensure that the overall section buckle, but the local or the part of the section should not buckle. So shear connectors are also required to transfer shear between the elements of built-up members that is produced due to the buckling of the member. So actually, when the two members, we have two members like this and these are bent in this manner, so the shear stresses will develop between these two members. So as we have seen in the very first chapter about the concept of shear, so when we have two plates and we try to bend those plates, so they will slide against each other. But if we provide shear connectors or shear bolts, so in that case these shear bolts will resist the shear between these two plates, and the bending or the bending strength will be enhanced. The stiffness against the bending will be enhanced. So to resist the shear between these two elements of the built-up section, we need to provide shear connector so that the shear can be transferred from one member to the other, as well as their stiffness could be increased. And when these are connected with the help of these shear connectors, so the section will behave like a single unit. So here we can see, so these are the shear connectors. We can say these are the lacing and these are battens or tie plates. And the slenderness ratio of this individual part should be less than the overall slenderness ratio of this section, of this built-up section. So following notations are used for the further discussion of the effect of spacing of shear connectors. So actually we need to consider the modified slenderness ratio when we use this lacing element as well as this tie plates. So here A is the distance between connectors. So the distance between connectors, the clear distance between the connector is equal to A. R is minimum radius of gyration of the individual components. So if we see this C section, so the radius of gyration of this section, the minimum radius of gyration. So A over Ri is equal to the largest column slenderness ratio of individual component. So this individual component, this portion, so A over Ri is the largest slenderness ratio of that component, corresponding to x-axis, y-axis, z-axis, or whatsoever is the weak axis. KL over R naught is the column slenderness ratio of built-up section. So the slenderness ratio of built-up sections. For example, we have built-up section like this. So the slenderness ratio of this built-up section will be KL over R naught. And KL over Rm is the modified column slenderness ratio of built-up member. So we need to modify the slenderness ratio in case of built-up section when we have these shear connectors. If buckling mode of a built-up compression member involves relative deformation that produces shear force in the connectors between the individual parts, the modified slenderness ratio is calculated as follows. So for snug-tight connections, we can calculate the modified slenderness ratio by using this expression, KL over R square and A over R square. And for welded connection or fully tightened connections, so we need to see if A over Ri is less than 40. So the modified slenderness ratio will be equal to the actual slenderness ratio of the built-up section. But if A over Ri is greater than 40, in that case, we need to calculate the modified slenderness ratio by KL over R square plus KIA over R square. So here Ki is 0.5 for angle back to back like this, 0.75 for channels back to back if the channels are like this, and 0.86 for all other cases. So by using this expression, we can calculate the modified slenderness ratio. But here one thing which need to be noted, that we only calculate the modified slenderness ratio when we have relative deformation between the parts of built-up section. So we can visualize this thing over here. So KL over R modified should only be used if buckling occurs about such an axis such that the individual member elongate by different amounts. So for example, if we see this angle section which is back to back, so here if we consider this x-axis and the bending about this x-axis, so in that case whatsoever will be the deformation in this channel section, the same will be over here. So this, for example, this portion is in compression and this portion is in tension. So both the members have similar value of deformations. So in that case, we need not to consider the modified slenderness ratio. But if it bends about this y-axis, so here one member will be in compression and the other member will be in tension. So in that case, there will be relative deformation between these two components. So for that, we need to consider the modified slenderness ratio. So in that case, we need to consider the modified slenderness ratio when there is deformation, relative deformation between these two elements of the built-up section. So one will be in compression and the other one will be in tension. So the slenderness ratio of individual component between the connectors Ka over Ri should not exceed 75% of the governing slenderness ratio of the built-up section. So the slenderness ratio of individual member A over Ri should be less than 0.75 of R maximum.